Core Concepts for Open Architecture AV Design. Chapter 13. Control Modules and Custom Logic. The learning objectives for this chapter are: explore Symetrix Composer's extensive set of modules geared towards logic and control. Place and wire control modules in design view to create signal paths that process and route data. Define string output and network string output modules and their use in controlling third-party devices. Use control modules to scale and taper control of external third-party controller audio signal. Explain how control modules can be used to create an emergency system. Utilize control modules to accept a control signal from an external third-party controller to recall presets. This chapter covers control modules and custom logic. Symetrix Composer has an extensive set of modules specifically geared towards logic and control. Composer is the Windows open architecture application used to program Radius, Prism, and Edge DSPs, Symetrix Dante analog input-output expanders, and select third-party Dante endpoints. Control modules and custom logic may be used in a variety of ways, like triggering an emergency system mute. Control modules and custom logic can also be used to change camera position based on microphone signal. They may also be used for a variety of audio applications. This may include muting a microphone or paging system, including control over Dante, as with this Audio-Technica mic. Please answer the question at the bottom of the page to continue. Symetrix Composer has an extensive set of modules specifically geared towards logic and control. Although they are used to control various aspects of an audio design, in most cases, these modules handle data, not audio. The Control Modules section of the Composer toolkit includes various modules for management of both hardware and software logic and control functions. Modules include control inputs like buttons and faders. Control processes modules also include inverters, ramp processors, and level detectors. Control logics, including the 2-to-1 multiplexer, delay, and 4-input logic module. Control accessories, which contains preset triggers and audio level detector. Additional modules include string output, network string output, and local logic outputs. Additionally, there are sections that include both control signal packers and unpackers, as well as remote monitoring modules. Control signals are expressed in percentage values from 0 to 100%. They may be continuous, varying smoothly from 0 to 100%, or Boolean, which may be either on or true corresponding to 100% or off, or false corresponding to 0%. Control modules are placed in the design view of a DSP and wired together to create signal paths that process and route data. The control modules are visually distinguishable from audio modules by their wiring nodes. Notice the flags on the control nodes. String output and network string output modules send out a text, ASCII, or binary, hexadecimal, string every time its control input changes from low to high. Both modules send UDP or TCP commands to third-party devices, such as turning on a projector or changing a camera position. String output modules can also send commands over RS-232. When using the string output module for UDP or TCP, it automatically responds to the last IP address that it communicated with. This module does not have an option to specify the IP address to communicate with. For that option, use the network string output module. In this example, control modules are used to scale and taper end users' control of an audio signal from an external third-party controller. In the toolkit under Control Modules, Control Inputs, add a 1-input remote control number module into the design. Double-click the module and enter a control number. Under Control Modules, Control Processes, add a scalar module and wire it to the 1-input remote control number module. Double-click on the scalar module to scale the control signal, limiting its upper and lower output values. Under Control Modules, Control Processes, add a linear to log taper module and wire it to the scalar module. Open the taper module to adjust its parameters for the desired taper. Under Control Modules, Mixers and Gains, add a 1-input VCA module and wire its control input to the taper module. This VCA module controls an actual audio signal using the control signal in this example. This is an example of creating an emergency system mute and unmute scenario. The logic is triggered from the external control inputs to either mute or unmute all of the outputs on the hardware in the site file. In the toolkit under Control Modules, Control Inputs, add a 1-button momentary module into the design. Under Control Modules, Control Accessories, add a dual preset trigger module. Under Control Modules, Control Processes, add an inverter module. Wire the output of the one-button momentary module to the first preset trigger. The input of the inverter connects to the wire between the one-button momentary and first preset trigger. The output of the inverter is wired to the second preset trigger. Open the one-button momentary module. Right-click the On button and select Setup Remote Control. From the Setup Remote Control window, choose the local analog input of the DSP that the emergency switch will be connected to. Then use the Select Analog Control drop-down menu to assign the analog input that the switch is connected to. This example uses switch 1A. The next step is to assign the presets. Open the Preset Manager. Presets 999 and 1000 are created by default in every Composer site file. Preset 999 mutes all outputs and Preset 1000 unmutes all outputs in the site file. This includes Dante outputs or transmit modules. Open the first preset trigger and assign it Preset 999. Now open the second preset trigger and assign it Preset 1000. When the button of the one-button momentary module is on, it sends 100% signal to preset trigger 1, muting all hardware. It also sends 100% signal to the inverter, which in turn converts that to 0% output. When the button is off, the inverter converts the input of 0% control signal to 100% and triggers the second preset, unmuting all hardware. This allows recall of two different presets using a single button. In a real-world scenario, you may need to reverse the on and off levels of the momentary button to match what your physical input configuration is with respect to normally on or normally off. Another example of how to utilize control modules is to accept a control signal from an external third-party controller to recall presets, then send a control signal back to the external third-party controller to indicate which preset was last recalled. In the toolkit under Control Modules, Control Inputs, add a 4-button radio module to the design. Under Control Modules, Control Accessories, add 2 dual preset trigger modules. Wire the 4-button radio module to the preset triggers as shown. Add a 4-input logic module from the toolkit, Control Modules, Control Logics. Add a 4-input logic module from the toolkit, Control Modules, Control Logics. Open the 4-button radio module. Since radio buttons are being used in this example, assign a single control number for all 4 buttons. This control number is being used by the external third-party controller to select the preset to be recalled. Right-click the fader of the 4-button radio module and assign it a control number. Next, open the 4-input logic module. The input LEDs provide feedback to the external third-party controller. The LED feedback is used to indicate which preset was last recalled or what could appear as active to an end user. Right-click on each LED and assign them a control number. Next, open each preset trigger and assign the preset numbers. The final step of this example is to enable push for all assigned control numbers. Each control number that has push enabled sends its control data to the external third-party controller anytime its value changes. Open the Tools menu and select Remote Control Manager. All assigned control numbers are listed in the Assigned Control Numbers tab of the Remote Control Manager. Select all control numbers to be enabled with push. Then, select the Enable Push button. Each control number that has push enabled sends its control data to the external third-party controller anytime its value changes. The configuration process of the remote control features for each supported third-party Dante device is the same. This example demonstrates configuring a mic switch and LED operation for an Audio-Technica AT-ND971. In this example, a Radius NX12x8 with the VoIP card installed is being used. Add a Radius and AT-ND971 from the toolkit to the Site View page. Right-click the DSP and select Configure I/O cards. Select the 2-line VoIP interface card and select OK. Double-click the DSP to open the Design View page. Under Network I/O Modules, Receive Modules, add the receive bus from the AT-ND971. Under Mixers and Gains, add a mono gain module and wire it to the Dante bus. Since Dante receive buses don't have digital trim, this module provides the ability to trim the audio being received from the AT-ND971. In the toolkit, under Conferencing and Paging, Acoustic Echo Cancelers, drag in a new custom AEC module. Change inputs to 1 and hit OK. Once placed, wire the gain output to the in number 1 of the AEC module. Double-click and open the AEC module. Next, add a mono gate from the toolkit under Dynamics, Mono Gate. Wire the mono gate output to the TX1 of the VoIP output module. This takes the near-end signal and sends it over the VoIP network to the far end. Now that the signal path has been created, set up the control for the mic switch and LED control on the AT-ND971. This will allow the button to both mute/unmute, as well as change LED color to indicate its current state. We begin with a one-button momentary module from the toolkit. There are supermodules pre-built that allow for configuring the state of a button, such as the one-button processor. This allows for push-to-talk, push-to-mute or toggle functionality to the AT-ND971. Import the one-button processor supermodule under Supermodule Library, import supermodule, examples, tools, one-button processor. With the one-button processor supermodule added, wire the one-button momentary to the input. Right-click on the one-button processor supermodule and choose Open Design. This shows the inner workings and functionality of the supermodule, how our control signal gets from the DSP to the AT-ND971, and determines the behavior of the LEDs. In the toolkit, under Control Modules, Control Outputs, add a Remote Logic Output module. The Remote Logic Output Properties window automatically opens. The third-party devices you want to control, in this case the AT-ND971, are found in the Remote Unit drop-down. If multiple devices are within the site file, the topmost will appear by default. Once the unit is selected, the options available for control of that device specifically are found in the Logic Output drop-down menu. The first and used option will auto-populate the list by default. 2 Remote Logic Output modules are needed for both red and green LED control and are wired as shown to the corresponding outputs on the one-button processor. Open the one-button momentary switch, right-click on the On button and select Setup Remote Control. Locate the third-party device, AT-ND971 Dante mic, and select. The Select Analog Control drop-down will populate with the options available for the device. In this example, only mic switch is available. Click OK. If you have superimposed assigned remote control numbers enabled from the Tools menu, a green flag with the letter M will appear upon the button, indicating that the mic's physical button is now tied to it. Now that the LED functions are done, we need to control the audio path. Open the Gain module following the Dante Receive bus for the AT-ND971 and right-click on the Mute button. Select Setup to Remote Control. The Setup Remote Control window will open. Locate the Control Signal Assignment option. Control signals allow some parameters with Composer to reflect the state of other parameters directly without a control number and are treated as one control. Open the Select Control Signal dialog via the button and select the One-Off option under the one-button processor. The control signal is now assigned and is verified in the readout area. The mute function is now tied to the off-red state of the one-button processor, and CS appears on the button to confirm. Depending on the LED state of the microphone, the audio is muted. In other words, when the red LED is active, the AT-ND971 is muted. By double-clicking the one-button processor supermodule, the control screen is displayed. This supermodule controls the behavior of the mute function and button press relationship. The indicators show if the button is pressed and which LED state is active. Each microphone can be set to push-to-talk, push-to-mute, toggle, or disable. Composer has an extensive set of modules specifically geared towards logic and control. Although used to control various aspects of an audio design, in most cases, these modules handle data, not audio. Control modules are placed in the design view of a DSP and wired together to create signal paths that process and route data. String output and network string output modules send out a text or binary string every time its control input changes from low to high. Both modules send UDP or TCP commands to third-party devices, such as turning on a projector or changing a camera position. String output modules can also send commands over RS-232. Control modules are used to scale and taper end users' control of an audio signal from an external third-party controller. Control modules can be used to create an emergency system with mute and unmute scenarios. An example of how to utilize control modules is to accept a control signal from an external third-party controller to recall presets, then send a control signal back to the external third-party controller to indicate which preset is active. The configuration process of the remote control features for each supported third-party Dante device is the same.